Hi friends, good morning. How are you? In the last class, I have given you the characteristics of D block elements. Am I right? Can you tell me the points? Do you remember that? Yes or no? Okay. They have the variable oxidation state. They form the colored compounds and they have the similarity in properties period wise and group wise. Okay. Then what is oxidation state? In the last class or last year you have learned about that one. Then do you know about valency? What is valency? It is the number of electrons gained, lost or shared during chemical reactions. The valency of chlorine is 1 and its oxidation state is -1. That means it has to accept 1 electron to attain stability. Then the valency of oxygen is 2 and its oxidation state is -2. That means it has to accept 2 electrons to attain stability. Then the sodium has valency 1 and its oxidation state is +1. That means it has to release 1 electron. Is it clear? Now I think you understand what do you mean by the oxidation state. Now we can go to the D block elements. Then iron. You know that iron is having two oxidation states, +2 and +3. Then see this one in FeCl2. It has the +2 oxidation state and in FeCl3 it has the +3 oxidation state. And how does it happen? See this one. The electronic configuration of iron is 3d6 4s2. 3d6 4s2. And when it releases 2 electrons, that is 2 chlorine atoms in FeCl2, it has to release 2 electrons, that is 4s has 2 electrons, that 2 electrons are lost by iron. Then the remaining configuration is 3d6. Am I correct? In FeCl3, 3 electrons by 3 chlorine atoms and at the same time you know that its remaining configuration is 3d5. That is 2 electrons from 4s subshell and 1 electron from 3d, that is penultimate shell. It is named as penultimate shell. That is in FeCl3 iron lost 3 electrons. That is 2 electrons from the outermost shell 4s and 1 electron from the penultimate shell 3d. So the remaining its electronic configuration is 3d5. Is it clear? So you have to be very clear about the electronic configuration of these ions Fe2 plus and Fe3 plus. Is it clear? Now we can consider manganese. Mn. See this one, electronic configuration of Mn is 3d5 4s2. See this one, 3d5 4s2. And in MnCl2, its oxidation state is +2 and its configuration is 3d5. Then MnO2, its oxidation state is +4 and its configuration is 3d3. Then Mn2O3, its oxidation state is +3 and its configuration is 3d4. Then Mn2O7, its oxidation state is +7 and its configuration is 3p6. How does it happen? See this one, the first one, MnCl2 +2 configuration or +2 oxidation state. That means this 4s has 2 electrons. These 2 electrons are released and the remaining 3d5. Is it clear? It combines with the 2 chlorine atoms. In MnO2, you know that MnO2 +4 oxidation state. So 4 electrons has to lost. That is 2 electrons from 4s and 2 electrons from 3d. The remaining is 3d3. Then in Mn2O3 +3 oxidation state, then the remaining it is 3d4. That means 2 electrons from S subshell and 1 electron from 3d. Then here it is plus 7 is the oxidation state. So it has got only 3p6. 7 electrons are lost. Then how does this oxidation state obtained? Last year you have learned by putting X for this element in the various compounds. See this one, in MnCl2 its oxidation state is plus 2. You know that. How does it comes this plus 2? See this one, put a X for Mn. We know the oxidation state of chlorine, that is minus 1. Minus 1 into 2, that is minus 2 is equal to 0. So X is equal to plus 2. That means you got plus 2 oxidation state. Then in MnO2, see this one, Mn, put Mn, X, and for O, it is oxidation state minus 2. About 2 oxygen atoms are there. 2 into minus 2, that is 4, minus 4, that is equal to 0. So X is equal to 4. Like that last year you have learned and you have done many problems like this. Then from this you can understand how can we find out the oxidation state of the considered element in the compounds. Is it clear? See this one, Mn2O3 2x, put Mn 2x, Mn2 2x, then 3 into minus 2 is equal to 0. So 2x minus 6 is equal to 0. 2x 6, so x is equal to 6 by 2, 3. So likewise this one also for plus 7, how does it obtain plus 7? See this one, Mn2O7 2x is taken as 2x, then oxygen valency or oxidation state minus 2 into 7, then is equal to 0, then 2x minus 14 is equal to 0. So x is equal to 14 divided by 2, that is 7. So I think you got the idea. That means last year you have already learned that one. Then this year also this column you have to fill it up, and how does we will get to the electronic configuration of ions. That is Mn, which are the ions Mn2 plus, Mn3 plus, Mn4 plus and Mn7 plus. I think you got the idea. Okay. Thank you.